Alright, let's get this started. So yet another S19 stream. Obviously we get more of these lately because first of all the warranties are starting to to be passed for most of those, and because obviously at the moment with the rates we have they are the most profitable Bitcoin miner, and so obviously people are going to be more inclined to fix miners that are generating revenue right now. Um, we still are receiving a decent amount of 17 series as well, though. And I know today we'll get another drop off of 17 series. So some people, and I see that more and more, especially lately, more and more people are starting, to prepare. I think for what we can expect to be a coming run into Bitcoin. And so a lot of people, well, not still a lot of people, but there is more and more people that are starting to perceive that, and are starting to fix even those miners that are unprofitable at the moment, but that we all know that are gonna get back into profitable territory very soon. And so without further ado, let's start for this hashboard. Today I'll just be doing the hashboard here. If I recall correctly, I don't have a label on it right now with the issue, but if I recall correctly, in the unit, we were detecting 30 chips for that hashboard. Um, so let me bring my screen there. And we'll start with the boring part, just unscrew those heatsinks. And as always, I forgot what I put my screwdriver, and there it is. So let's get started with that. Um, so S19j Pro hashboard is what it is. These are BM1362 chips, and we'll see exactly which one this very hashboard has. So for those that are involved in 19 series repair, you might start to notice that it's starting to be very, very confusing because, well, first of all, Bitmain is not applying the right labels on all of their units. So some units are labeled as simple S19 when really they are, for instance, S1988. Some of them are S19j straight up, labeled as a simple S19, so that gets confusing if you're not too aware. And then you'll also get different revision, different models of the S19, S19j, S19j Pro, etc. And you have like those, I think we're now at 15 different models of 19 series miners. And so you got all those different models with different revisions and different components. So just for the S19 J and J Pro family, you get BM1362AA, BM1362AC. I believe there is also AK, AI, and AJ. So it's starting to get crowded. Um, if we base ourselves on the 17 series and also on the chip layout, like the pin in, pin out, they should be able to be retrofit, but we did have some difficulty from time to time to retrofit some chips. So it's also something that adds to the difficulty where if you have, for instance, a AA board and you're trying to use an AC chip, so far our experience hasn't been as great as with the 17 series where obviously on the domain of reasonable you could retrofit some chips that have different revisions. So we'll see exactly, we'll try to produce, that same document we did for 17 series. If you don't know actually the one I'm talking about, you can have just a simple Google research. Go ahead and look for our BM1397 replacement guide from Decentral, and you'll see we have a big, like a big sheet that's all divided with all the different parts, all the different programming that's used for those chips, and the different values that they're being run at from the manufacturer, the different models they've been used to be manufactured. And so this gives a lot of hints whenever you're getting, one hashboard, because they're like they can be retrofit, but sometimes there are some hashboards that will reject some of those other type of chips, and in that case you really have to refer to the same bin number or same chip revision, so either it be AD, AJ, AI, AH. In any case, 19 series has been a bit more confusing so far on that regard, but it's also because we still don't have as much information as we did with 17 series and as much experience also. So, but now it's starting to pour in much more. Also, we did some live streams past week about D7 and L7, and since we did those streams, there is more interest. We receive more, more people are opening tickets for those very hashboards, so it's possible we see more of those in the streams as well. As a matter of fact, I was working on D7 boards this morning and yesterday. Some of them took me like 20 minutes to fix, while some others took me like 3 hours. Still figuring out some of the, the issues and like the internal working of the board. That being said, let's go ahead and see what the hashboard is getting us on the tester here. Now that it's all uncovered, and oh, and this is BM1362 AI chips. So we'll have to see because I don't think I have those in stock right now, so that might be an issue for our fix of today. I might have to source more of these because since we have all those different revisions, you have to keep stocks of every of those each revisions. Um, so sometimes it just happens that we run out of one specific chip type. And so AI, I don't believe I have any in stock. I'll go ahead and have a look if we can proceed to the repair. But from top of mind, I don't think we have any more left in stock. So obviously, before starting, we want to have a physical inspection of the board. And so let me just go ahead and do that. And quick like that, looks like everything is decent and in place. Let me also make sure that that ticket number with the customer information is not visible for the stream because we don't want to leak any private information. So just give me a moment there. Hey Angali, happy to see you on the stream. All right, let's get started. So we always make sure before powering on our power supply, we double check our poles here, make sure everything is good. My little trick that's been useful so far doesn't mean it will last in time, but so far on Antminer models, when you see the IO port, the one next to it is the negative port. And so that's what I use as a trick, make sure everything is in place. Now I can power on my power supply and we'll feed it 13.6 volt. Let me go ahead and make sure we're right on target. And here we are. All right. Now let's start the test. And we're getting to 61. So let's stop the test for now. We won't be needing any more power on the board. And we'll just start and do our diode measurements. So let me bring multimeter on screen, like so. We'll put ourselves into diode mode. Use our red probe to inject the voltage and make our measurements with the black probe. So it turns out that it's the one that I've uncovered here, but it really is just random. So the one that I removed the thermal paste here is actually the one where the signal is stopping. So let's go and see what's happening in that area. And just quick like that, values are, at least with the diode measurements, are looking good. Um, and just as a reference, we can go ahead and come here, go and measure. So here we have clock 771, TX 771, RX 330, BI 771, RST 700. And let me come back here. So this will be clock 770, 770, 330, BI 770, and RST 700. And I believe, yeah, I believe that's normal here. Yeah. The 19th generation is, it's a bit more all over the place also. So the values used to be essentially always the same or almost on 17 series, while the 19 series, you have the J and the normal and the A and everything, and they all have their own values. And so it can be a bit hard to keep with. Now, diode wise, so resistance wise, the chip resistance is looking all right. One more thing we can go ahead and measure before we start to run test again and run more current through the board. We can go ahead and measure the resistance in that area. So we'll need to remove that plastic film. So I was able to test through the plastic film because essentially you use your multimeter to to pierce through the plastic film. It's a very small plastic film. Um, but whenever you want to start to work on the board or do more serious diagnostics, like for instance, we want to look at the resistance around that area, see if the values are right. Because if the signal can't go through, well, resistance should be good because we measured the signal resistance, and so it indicates it should be good. But just as a good practice, we want to go ahead and look at that. And why the reason I try to avoid using all the tests while running the board, running current through the board, is because I want to avoid creating more damage. And so if you have some damage to a chip or to a neighbor component, and you start to shoot current through the board, obviously it's possible you create more damage to other components that are surrounding. And so you want to avoid that. Let's go ahead and remove this here. It's also something that's possible to see the issue be somewhere else on the board, but the tester to detect the issue at this very chip there. So it's possible that it's a false, a false error that it's detecting 61 chip, but many things can happen actually. So it can be some kind of ghost chip where one of these chips here at a certain baud rate won't answer, and so that makes it what I call a ghost chip. And in that case, the tester is going to be able to count 61 chip when really it might be getting to the 62nd or 63rd chip being an issue. But it's possible that one or two chips in the example I just gave is not giving the proper answer at a certain baud rate and is therefore undetected. Normally, when we have that kind of issue, what we'll do is we'll jump the either the clock or the return signal. In that case, that would be the clock because our return is looking fine. And so what you'll do is for each domains, you'll need to go and bring one of your probes to, for instance, if you want to jump the clock, you'll go to the 0.8 and you'll short it to your clock signal. If you want to go short the Rx, in that case on J, remember it's 1.2, and so you'll go to that capacitor, use the 1.2 from that domain, and jump it to the suspected chip to narrow down on your issue. So I wanted to go ahead and measure the resistance around. Let's good. 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 So this is going here. We can still look at the one just after. Good. But I suspect everything is going to be good. But even though you don't want to run on assumptions, because sometimes you get caught by those assumptions. And so now I always try to go ahead and measure everything against my assumptions, because I want to make sure that my reading of the situation is actually accurate, because sometimes just because of that assumption, you misdiagnose your board and you start working on other issues. And we have Sasha Cool Games. Hey Sasha, how to protect the board after repair? You can't glue the same film. Well, first of all, there are two ways to operate with that. You could just, try to tear your film apart, like without removing it, and just put it back with and tape it back with thermal tape like this one. And so this will put it back in place, and it does the same job. But really, that film, they started to remove it from the latest manufactured units. It's more of a pain in the ass, really. And what happens really in the units when those boards run for a while is all the crap and the dust is going to get stuck in between. And so, anyways, whenever you're going to want to clean your Hashboard, because it can create serious problems when there's too much crap under that film, you're just going to want to remove it anyways, clean your Hashboard from and clean all the thermal paste that's going to be, becoming all dirty, and that won't be doing as an effective job as it does now. And what we do after then, we'll have a ultrasonic cleaning of the boards, reapply new thermal paste, and everything is good, and you get very optimized running machines. All right, so back at 13.6, and we have a S19j Pro, so let's go ahead and select that and start our testing. Everything is in place. Let's do that. We're still getting to 61, so we'll have to resort to DC voltage measurements. In that case, you want to ground to the same domain here, and we'll look at this one, the TX. I believe the clock is low here. Let me just go ahead and look at this one here. 300. Sorry, X950. See the BI here is maybe I'm not on the right pad here. All right, that's more like it. Oh yeah, that makes much more sense. So I was just on the wrong pad to make my measurements there. 1.2, 537, 1.2. PI is good. RST looks good. That's all right. Let's go to the next one. RX here. So that RX is very high here. That's the one at the end of the domain. So that would be the 63rd chip. Just want to measure again the one just before it, and the 60 is looking fine, but the 60, let me see again. 60 second. No, actually, sorry about that. I was just on the wrong domain again. So this is looking all good. Let me just go ahead and fetch my values instead of going on top of my head, see if there's anything. I'm not catching on. We varnish the board after repair with plastic. Do you mean you're using like liquid acrylic that you let dry to cover the components? I mean, you could do that. The one use case I definitely see for using acrylic, if that's what you're doing, is for especially for the 19 and 19 Pros. Not J's, not A's, nothing, just 19 and 19 Pros. Those one they have those uh, here on the corner of the hashboard, like here and here and here. You'll have resistance and capacitors that are connected to the temperature sensors, and they are leading to the temperature sensors to fail a lot of time, especially when they're in an environment that's how to say that is favorable to corrosion, if that makes sense. So those parts and those pads even can get corroded. It's something we've seen, and I showed it in the second stream we did actually. Um, and so those pads are just gone, and now you have to wire new, essentially new pads where you'll attach your resistors to. So that can be very annoying. Go ahead and just bring my values on screen. And let's look at the boost circuit as well, but I don't think that's where the separation would be. Oops. One. Okay, so again, I'll just refer to the values we have on board because I can't find my document at the moment and I don't want to lose too much time on that. So let's go ahead and start the test again. Ground. Can't make it true. Right, 1.2. So it's actually my clock that's high here. It seems to be high on all the domain. Let me just confirm that again. And in diode measurements, let's go back to diode. Here we can go here. clock is this one here, 750, 750, 750 again. So it looks like that whole domain has weird values on clock. So we'll go ahead and look at the domain LDOs to make sure that our LDO is actually working properly. The ASIC repair tester is very expensive. It is, although when you do that the whole time, it pays for itself, and that's why I see a lot of companies trying to do vertical integration, and they'll start to hire their own repair guy, and in my experience, I've talked with a lot of those companies. They'll have like one or two or even three techs doing that on top of doing normal maintenance. And first of all, without specialization, well, those people have to master or at least to know all that knowledge, from maintenance up to repairs, and it leads to a lot of lost time. Leads to a lot of, I think, staff frustration. It leads to inefficiencies, and because those companies they try to keep everything in house and they try to save every buck, they end up losing more instead of just shipping it to repair centers such as ours. I'm not just preaching for my own house here. I just see it and call it like I see it. Like, trying to do everything in house is can be good. Like, if you have infinite amount of capital and you can hire a lot of staff for your maintenance and more staff for your repairs and more staff for every steps in the way. But getting everybody specialized on like every single part of labor to run your mine and to maintain your stuff is just won't cut it. Also, repair centers such as ours, we have like 30 members in the staff, and so there's a lot, of complexity about fixing those dashboards. Myself, I always go and turn out to my employees because I'm not with a background in electronics. With a background in IT and networking, and so I do those streams and those repairs because I actually very much enjoy it. But like without a team behind it, like that would make it so less inefficient, so much more inefficient actually, and so less efficient. So it depends really. So in your case, to answer what your comment, Sasha, um, those testers they'll be expensive if you're just fixing one dashboard a week. But if you're fixing 8 dashboard a day, like we do per tech, well, in that case, they pay for themselves. Let's remove that heatsink as well because I want to get a proper access to my LDOs there. Well, yeah, ASIC repairs in general is actually expensive. The parts are expensive, the chips are expensive. You need to stock on every of those single parts. And again, for a facility that's not necessarily doing that all day with all of their staff, you have to source, that chip here. You have to source all the different resistance, all the different LDOs, all the different type of chips. Um, you need to source also for your PSUs, for your control boards, for the wires, the fans, everything, because you want to be able to repair those units as fast as possible to get them hashing back as fast as possible. And so if you don't have those chips in stock, you can obviously do it, but then it's going to require 2 or 3 weeks to get your parts and to finally get that board fixed. And so again, it leads to a lot of inefficiencies in my opinion. All right. Get back to DC measurements. Make sure our poles are good, and we can power on, start the tester, and we'll have a look at our LDOs. So we can go ground to that domain here. That's the one we want to look at. Okay, there we are. And we'll go ahead and look here. 70 is a bit on the low side. 68. 93. So see, this is abnormal. I'm not getting normal readings on my LDOs right there. But now I can see more issues starting to pop on the screen. So we're not getting, oh, my bad. Need to select J Pro here. Let's go ahead and start again. But the measurements should be the same on the LDOs though. And if you want to be even more precise, I can have my tip here, getting back to 61 on the screen as you can see. But even then, that kind of reading is not normal. I should be getting 1.2 and zero point 0.8 from the other LDO. So we can see that something is probably shorted. So two things. There might be more than two issues with that board, but two things that we normally see, that we often see, is either it's going to be LDO problem, or it might be a chip that's shorting and that's creating that output to be influenced. Most often than not, it's actually a chip problem. Like again, as always, I always say it on every streams. It's maybe 80%, maybe even 90% of the time a chip issue. So I mean the ASIC chips right there. And so since it's with this domain here, so one more thing I can do is go back to my diode measurements, but this time we'll measure the capacitors that are used for the 0.8 and 1.2 track. And we'll try to see if we can see any anomaly there. So let's go ahead and do that. Normally, so let me just bring the microscope so you can see, and let's put the multimeter on screen. So see here we have two capacitors, this one and this one. Normally you want to measure inside, and that is where you'll see your values. So we can get rid of that paste right there. And do we have the multimeter? Let me try to put the light, see if that avoids a bit of the light reflection. I'll have to fix that for some of the future streams at some point. So 228 here and 196. And now I'm unsure about what are the values I should be seeing here, so I'll just go ahead and measure against what I know is working on that board. So let me bring you with me if I'm able to. Here. So see here I'm reading 468 and 253. Right, 253 and 468. So getting back to our problematic domain here. Get 240 and essentially 200. So I just want to once more 470 and 250. 470, 250. Let me just note that down. And again, I'm using my numpad, so everything is moving on the screen. Sorry about that. Here you go. So definitely something's going on that domain. and it seems to be related to the LDOs. So that's identified and confirmed now. Seven 200. So see, the neighbor domain is all good. It's reversed because it's going the other way, but the measurements are good. So definitely something wrong with this domain here. And to be honest, I do have one board that has the exact same problem right now, and I've been bashing my head all over that board, and I still haven't fixed it. And on that other board I'm talking about, I tried changing the whole three chips of that domain. I tried changing my LDOs. I changed the resistance and capacitors that was surrounding. Even though all my, the values were looking good, I changed it anyways just to, to try to get through that board because nothing that I would do would go through it. And it's still not working, so I, I fear this board is going to be something similar. I hope not. So now I gotta say that this kind of issue is a bit annoying to me. So hopefully we'll figure out that solution together on that stream. But I can't guarantee it's going to be a fix for this one because I know I have the exact same problem on another board that's giving me a headache. I think we should just get back to the main area camera for now. So again, 90% of the time it's a chip issue, so I guess we'll probably just go ahead and change the chips. But I still want to look for some hints. Let's try to see if we can find some information about those LDOs. If there's a short that's obvious. Alright, so those two pins I think should be connected to ground, so that should make sense. What else can we look at? Well, we can have a look at the resistance around the LDOs. And again, I need to recall the values. I've looked just yesterday at a board very similar, and I've looked at those resistance, but I'm not sure the number exactly. It's not one of those values we get to see on each component, like for instance 33. It's not 33, I know. It's not 1.9K. It's not 4.7 either. I just need to remember which one it is. And now this won't show up. 923. Does that make sense? $580. 935. Let me just take a note of that. Again, I'm playing with the cameras by typing on my numpad. I'll try to keep that in mind and use my upper keyboard numpad. And let me see if we have more comments before I get back to it. That's it for now. Alright, let's look at those. 1 point... Ah, no wonder I was getting some weird stuff. Yeah, that's more like it. So I remember that value from yesterday. It was 70k ohms. Again, got cut using my um, side numpad. So 70K. Let's get, and let me bring back the multimeter so you can follow with me. So obviously when you're working with these boards, you have to be very attentive. And it's something that I notice with the streams. I can be a little less attentive to my multimeter mode. So make sure, obviously, when you want to measure the resistance, you're measuring, your multimeter is on test, is on resistance test, and not on diode test, because the measurements you're gonna get won't make any sense. But fortunately, whenever we put our attention back to it, we figure it out pretty quickly. So we also get 10K here on the left side. Let's just go ahead and see here what we get. 65. I'm gonna need to remove that heatsink here so I can go ahead and look at the other resistance. So whenever you're unsure, documentation can be useful, but you can also just compare to other areas on your board that will share the same values. And so that way, in my opinion, it makes it faster. And when you get used to it, like for instance, we're very like 17 series boards, I know them by heart because I did so many of those. I probably processed myself more than 1,000 of those hashboards. I'd say pretty confidently, yeah, I did more than 1,000 of those hashboard repairs. Um, so you get to know those values like by heart essentially. But 19 series, 9 S19 and S19 Pro, I think I did a lot, so I'm starting to be not too bad with it. 19j Pro, so far it's mostly my staff that did, and so I still have to process those values and remember. So we get 10K here. This is 60K and 60K. This here should be 10K. Yeah, we get it. And here should be 10K. Yes, all right. And this here should be, let's remind ourselves again, we should have one at 70, I believe, and the other one at 85. So this one's 70K, and this one should be 85. Let me get back here. 67 and what? Okay, so both should be 70. All right, back to it. 63K, so might be a bit low, and 63 again, but that might be caused by the short we have on that domain. So it's hard to say right off the bat if it's the resistance that are really bad, or if we remove those resistance, we could have a measurement and see if they have the very accurate value or if they're influenced by any short on the board. One more thing we can do again with continuity is we can get back to our ground here and see if we have any short. So this is touching ground on both sides. That seems normal. Here, 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 here. This. This. What else is there to look on that domain? This I did, and this, and this. All right. And again, we had the two pins here going to the ground. So let's just go ahead and look if that's a normal behavior. Now I expect those were going to be the two on the top. 1 and 2. Yeah, not the third. 1, 2, not the third. Perfect. So short wise, I'm not detecting nothing on that side. That's obvious at least. So it's probably going to get back to what I was saying to start with, and it's probably going to be a chip issue. So what we'll do is we'll clean that area, maybe make some room to make sure that the heat from our heat gun doesn't make damage or have that plastic film melt here. So I'll just remove a small part of that one. But this is annoying issue for sure. Now, if anybody that worked on these boards that's maybe watching the stream already had that annoying issue in the past, do let me know in the comments, and maybe we can try to save some time together doing that stream and get to a successful repair quicker. But I did have, and I still have actually, that board that I'm working on that has a very similar issue, and so whenever that's a great thing though, and that's another point to add on top of what I was saying just before. With repair centers such as ours, we process so many boards that we get to see so many different issues. But at some point, whenever one member of the team here sees one issue and finds the fix to it, most of the time when we see that issue again, it gives us a hint and we can start to look at that solution right away. And so we get much faster and faster and faster with each iteration and which new issues we find. Whenever we find that solution, we share it with our colleagues, and it allows us to process repairs much faster over time because we get to see each and every type of issue you can get with those hashboards. So for instance, bring us S17 Plus or S17 and you'll see those boards we process very quickly. Average process time would be about an hour. It depends, obviously. You do have some of those boards that have crazy issues, especially some boards that we've accepted in the past that we should really have declined. That like were filled with silicone, glue, all that kind of stuff, crazy stuff that made the repairs so much more painful. And so those repairs to process, like they probably triple, even quadruple the processing time. And so it makes it very unprofitable if you want to have a fixed pricing such as ours. That's advantageous. It makes it unprofitable for us to accept those boards, and it also creates some insatisfaction because the customers they get to create that expectation, and they'll think, that fixing all the boards should be the equal amount of time, but really it's not the reality. First of all, for instance, with that board, you can see it's a new issue I haven't figured out yet, so it might take me some more time. For instance, the D7s I was working on, I had one that took me 20 minutes, while the other one took me 3 or 4 hours because it's an issue that I needed to figure out. Now that I did figure out the issue though, next time I see it, it's probably going to take me 20 minutes to process it. Whenever one of my colleagues is going to see that issue, I'm going to be able to tell them the resolution I applied, and so it's going to make it that much faster. Now I really want to remove all the, even though it's non-conductive and it shouldn't create too much harm, I try to remove the surrounding thermal paste of where I'll be working. The reason why is because if too much thermal paste is stuck in there while you're doing your solderings, it is a possibility that that the soldering starts melting even where you're not working because it gets out all over the board, and some of that might prevent the proper balls to form on the chip legs, and that might lead to some kind of solder balls that can bridge or stuff like that. So you want to avoid that, obviously. You want to avoid creating more damage whenever you're working on a board. While it's a possibility, you do want to maximize your chances. Can even remove this here. All right. Let me take my tweezers. So I'll just remove the sideways thermal paste here that gets stuck. The cotton swab is not able to go and fetch everything. So, and again, I'm a bit OCD about that stuff, maybe, but I really like to have my area really clean when I'm working on. And so this is what it's going to get to. I'll remove those 3 chips here, and we'll try to measure the chips, see if one of the chips has any obvious issue. If not, maybe we can try to put them back, so it's going to process as a reflow. Otherwise, we'll have to try with either. I'll go and see if I have any AI left in the inventory, but I don't think so. If not, I'll need to try maybe with AC or AK chips, and we'll see what's up. So when it's on the sides like that, I feel more comfortable to do the bottom heating trick. So I just bring my heat gun under the table. Let me help you see, like so. And I apply heat directly under the chip. So it helps to to get the surface under the chip to be melted before removing the chip. You can do the same when you're applying the chip, really. When it's on the middle of the hashboard, it's a bit less. It's a bit more tricky actually to execute, and so in that case, I'll probably just go on the surface heating. And as some past observers from our stream have mentioned in the past, 19 series soldering is much more, first of all, the solder used is clearly more resistant to heat. And so it's much more, or should I say, much less malleable to work with. And so you have to be very patient, just let the heat do its thing, and then you remove the chips. Same thing goes when you apply back the chips. You just let the heat do its thing, let the solder get in place, put some pressure on the chip, and you're done. So obviously you can look at some hints, like the chips that are the chip legs that are gonna start to turn a bit shiny when you're eating and they're getting to that melting point. Here we have one, 2, and 3. All right, let's cool down the board a bit. And we can start cleaning the area. See my cotton swabs here. Let's bring the camera on the pads so you can see a bit what I'm doing, a bit more precisely. All right. I'll just change my iron tip there because I might want to work. Maybe you can see on the camera. Let me just show you right here. This pad here, you can see it's a bit more bubbly, so for sure I'll want to get rid of that. This one seems to be not sufficiently thinned, so it's probably just removing the chip that did that. It's alright, but we just want to fix it before we apply a new chip on the board. Alright, so let's go ahead and use that tip here. So what you can always do is see, especially because of that bubble we have on the middle here on the pad, and this one here, and the one that's actually just after it also has it, and it often does that with the 19 series. You can get some copper wick and get rid of that, so we'll probably do that as well. You can leave it on and sometimes it won't matter, but it's more it's a best practice to just get rid of it, so let's just do that while we're on it. Alright, so that's done with this one here, this one here. Alright, perfect. Alright. All right. So again, we'll clean the area. Remove that bad flex that's used now. That is done. You can see some marks still on the microscope, but I'm telling you it's pretty flat, so we're good there. Let's get back to our overview here. We'll just put this on the side a bit here. And we're into continuity mode to our multimeter, so that's perfect. That's exactly what I want. Let's remove those extensions. And we have some tests. We'll run some tests on our chips here. See if anything is standing out. So positive is always the smaller side, negative the bigger side. So this one is pretty much standing out in my opinion. All right. So, oh, damn, I should have it on the screen. I'm sorry about that. So let's try to run that again. So those two chips, I believe they're going to be good. Hopefully you can see on the screen. Let me bring them a bit more lower so you can see a side of the multimeter. And I wish there was a way to make the reflection a bit less bad on the multimeter, but we'll have to do with that for now. So positive on the smaller side and negative on the bigger side. The logic behind is really simple. You can see here the power is flowing through the dashboard and it's positive, negative, going positive, negative, positive, negative, positive, negative, like that all the way to the end of the board here. You can look, you just have to look at the flow, right, of the signals and the flow of the current, the power on the board, and it makes sense, right? The left side here is where all the power distribution is happening, and so it's flowing from that side to that side. Signal is going here, doing that serpent-like, pattern. And so for the ground pads that are under your chip, that's how you get to know the polarity is based on their location. So let's have a look at the two of the ones that I suspect are looking good. And so we can go ahead and measure. See on my multimeter how I started at about 3 ohms, and I'm decreasing of about 0.2 ohms each like seconds or so. And I really want to get rid of that light that's preventing you from seeing properly, because I wish you could see what I'm trying to show you. Again, here 1.9, 1.7, 1.5, 1.3, 1.1, going like that, right? But if I go to that chip here, what I saw is it started at 5.1 and got like almost straight up to 0.1. So let's see. 3.1. Oh, now it's decreasing, not too bad. But still, like it started higher and it decreased faster than the other two chips. So this one I still suspect there might be something going on with that chip. Doesn't necessarily mean, but if I would have to pick a guess, I would say this chip is the one that might be creating the short we just experienced. So we'll try to let me go and see if I have any AI chips in stock, and I'll be right back. So a bit like as suspected, there is no new AI chips that I have in stock. I did find though one that we suspect might be working. It's a used one. Let me just go ahead and make my little measurement trick here and see if it's a potential candidate. Yeah, it definitely is more decent than the one that was installed previously. So we'll try and use those three chips and reinstall, see what we get. So first of all, I want to give a bit of a cleaning to those chips. All right, so everything under is looking great once cleaned, so I'll be able to use those chips as is. Again, just to be able to do the bottom eating trick, I'll put my board oriented that way. We'll apply some flux. The flux I'm using is the AMTech 559. It's a question that's being asked more often than not. Solder paste, if you do want to know, we're using the Chip Quick. I use the one with the 6337 composition. I like the one that has T4 grain. And it took me to yesterday where somebody asked me if it was the thermally stable one that I was using. And I was actually clueless about the TS mention that meant terminally stable. And so, for those that don't know, terminally stable is simply the one that you don't need to refrigerate. And so this is the one I personally use. I know there's one member of my team though that likes the one that's refrigerated. Um, he's definitely been in this industry, well, I mean the repair industry for electronics for much more time than I did. He's been doing that for 15 years or so, and so I believe there's something to it. But the one that's terminally stable is doing just fine for me. All right, so let's start eating from bottom. And it's obviously a bit less comfortable when your setup is not, done for that. So what I see some technician doing is they'll have, they'll just cut or have desk adapted to it, and they'll just cut a hole on the middle of the table and have that area where they can just attach their heat gun, place the component they want to heat right on top of it. So this is definitely more useful than having to bend like I do, but it does the trick and it works for sure. I did a lot of soldering that way. For sure, yet less useful than just having a desk adapted to it. And so that might be something that I get in the future if I see more and more use to heating from bottom. Um, the 19 series definitely makes you think about it because as we've mentioned before in the stream, they require more heat, and eating from the bottom is definitely more effective. But if you work 17 series or even if you work watts miners, obviously you won't need that. So we'll see really if we want to if I want to get a desk like that or no. Maybe we'll just get, some stations that way that are designed really for just the 19 series repairs. Something that I'm looking more and more into is having, dedicated different stations. So you can have a station dedicated, to what's minor repairs, where you have your eat plate and stuff like that. Maybe stations where it's with air from the bottom for 19 series. Stations like the one I have right now that are more designed for 17 series. To be honest, we did so many 17 series repairs that like everything is optimized for 17 series still. Um, but now that it's shifting, might make some changes. Obviously, for advanced repairs, I'll be looking into doing some stations with those badass microscopes, much better than the one I have. But the one I have, again, it does the trick, right? And you can always get some better tools. If they make you more productive, then in that case, for sure, it's a good buy. But sometimes it's just like, it's just like in French we say un caprice. I think in English we'd say just something you want to be more comfortable. I don't have the exact word. Oops. This one on the middle, it annoys me a bit because when it moved and I lost some solder on two of the legs, and I'm not sure it's soldered enough right now, but I guess we'll have to see. On that side here, I just want to get rid of two balls that came from under the chip. One is taken care of. All right. Let's change the tip. I have a smaller one so I can try to go for those two legs that I'm not too sure about. Let's just give it a bit more solder. Just make sure it's all good before we proceed to our testing. This here is all good. This one here can still maybe adjust a bit. And so for that operation, since it's a bit less tricky, I'll be able to bring back the microscope on screen so you guys can see. I know it's not always perfectly appropriate the type of view you get. Sometimes you have our head all over the dashboard on the area we're working. And for sure at some point I'll make sure that you get a better view. Especially when I get, that microscope I can look over. I just haven't done that yet. I'm still, waiting to see how the market is going, because at the end of the day, you still have to look at that. I mean, that's how we've been in operation since 2016. Sometimes is not spending times, while some other companies that are much more capitalized than us, they forfeit, or they fail, or they straight up bankrupt. We're still here, and so I know sometimes it can be annoying, and we wish to make those spending, but you have to be very careful in those type of markets. Right. Let's just go like that. See those legs I was talking about? So see all the other are like having a soft, roundy, ballish look. While this one here, I don't think we'll get a better look out of it, it seems. Let me just try to get more solder here. Don't think it's gonna get any better, so we'll just test and see what it does. And worst comes to worst, we'll have to remove and resolder again. So I'll still, because it might not be yet perfectly cooled, so I'll still give it a bit of a cooling here with the fan, and we'll clean the area. We always clean the area between each of the steps. Um, at least the alignment and everything is looking all fine, so that's great. Nothing is bridging, nothing that shouldn't be there. Everything that should be here is still in place. So if anything, it's just going to be a small adjustment, but that's on the assumption that the chips we're using right now are going to be good, right? And so there's one that I brought that's a used AI chip, so it might cut it. It was looking good resistance wise, but it doesn't mean that because it's passing the resistance test that it's going to be good in any case. Resistance is just looking for the transistors and everything that's, the million of components that's forming the IC. It's just looking for the cumulative resistance of all of those tiny microscopic parts. But it might still be there might still be some kind of issue that makes the chip not working properly. All right. So before doing anything else, we'll start to do our diode measurements. Diode will tell us, first of all, is our alignment really good? And second, is the resistance of the chips as it's installed is looking good, right? So let's bring back our multimeter on screen, put ourselves into diode mode, and start measuring. So TX here, 740, clock 740, RX 320, around 330 is normal, 740 again, RST 684. RST I think is 700 normally, the measurement you'll see, right? Yeah, well, 690 seems to make sense, and we get 685. So yeah, we're on point. Let's go to the next one. So 742 for the TX, 742 clock, 320 for the return, 740 for BI, and 680 for RST, looking good. Let me show you the measurements on screen, like that with the microscope. For those that are trying to follow, this is some step we can see with a closer look. There you go. You have the multimeter on screen. It's not perfect. Again, sorry for the light reflection. So we'll start with TX. I get 740, 746, 749, RX 320, 740, 680. So that's looking good and normal here too. And the next one, 748, 749, 320, 748, 691. It's like 10 10 units over, but it's really it's still within range, so that's good in my opinion. Now remember, we had issues with LDOs, and we could measure those issues on the LDOs on the diode testing as well. So what we'll do is go back to the top here. Now we know signal wise and pin wise everything is aligned properly, and the chips should be working as is because we are getting the right values resistance wise. So now what we were expecting is one of those chips might be causing some kind of short or some malfunctioning chip that would cause the LDOs to give us the wrong values. So let's now test that theory and go back to our capacitors here. So remember, we measure inside, and let me bring back the values we expect because I don't recall them on top of my head. And we're expecting 470 and 250. So let's see what we're actually getting this time. 260 on that capacitor on the left, and oh great, 473. So this is very good news. It looks like we've made some progress. All right, so let's go to the next one. So we can measure even the one on top of the chip and the one on the bottom. Let me see, I'm just one chip too far. Here, 260, so that's close enough. And 474, that's great. All right, to the next one. 265, 465, looking great. So we might have done that repair here. 264, 475. So now signal diode measurements are good and our LDOs are good now. So this is very great. And just with that, we made it farther than that other board I was talking about. You know, that other board that I also have bad measurements on my LDOs. I even with I did what we did together, but I did even more than that. I even changed some resistance and capacitors that had the right values, but since I couldn't find the issue on that other board, I didn't do it on stream, so don't go ahead and look for that. So what I was saying is that other board that that this very repair is looking like, still haven't figured out my exact issue. And I did much more than that, and I didn't even still get the corrected values like we did here. So it looks like the AI chip I could find, it's a used one, but it looks like it's a working one, and it looks like my diagnosis about that wrong chip is right? Because we removed that one, we changed it with another one that I had, and it seems to have fixed our problem, and it just goes and corroborates with what I was saying earlier, where 90% of the problem, even if it's looking like an LDO problem, is actually just an ASIC problem once more. It's almost always the ASIC chips. And so again, before powering on your power supply, it's always very important to do a check of your polarity here, because that can create a lot of damage. And whenever you're not attentive enough, it's easy to just switch the two. And whenever you press that power button, sometimes the damage is permanent and there's no going back. So we want to make sure that everything is good. I'm powering at 13.6 volts. My tester is now set on the Antminer S19j Pro setup here, and I can start the test and see what's happening. And there we have it. So that was it. So my diagnosis of this board was pretty accurate, and I'm pretty happy that the only chip I could find, unfortunately it's a used chip, but at least the only chip AI I could find was actually a working chip. So I'm happy about that. So this is going to be a quick repair for that customer. I think he's brought that board to us maybe 2 days ago. And so 19 series, really, they're much, for the most part of them, they're actually faster than 17 series to fix. Most of the time, there's only like one issue located on the board, while those of you that are used to working with 17 series, you might know there's more often than not, there's like 2, 3, 4 chips, even sometimes even 5 chips that you need to change on a board. And so that gets pretty annoying, but it is what it is. That 17 series generation has been a bit more problematic from the get-go. Even new units had some issues. Sometimes we can tell just by the look of the board that it's a unit that essentially never ran. But one more thing that I notice is creating a lot of damage is a lot of people are overclocking their 17 series, right? And they've been doing that for a while, for a year or maybe 2 years. And so obviously when you run over the performance expected from the manufacturer, well, that's going to create issues, that's going to create damage. And so whenever you bring those units to be fixed, don't be surprised if it's requiring 4, 5, 6 chips to get fixed. But 19 series so far are pretty straightforward. There are some of those, like again the D7 I was mentioning at the beginning of the stream. I like most of the boards. I'd say my average is probably even 30 minutes on D7s. But there is one board that I had to scratch my mind and find that issue. It took me 3 hours. But now whenever I'm gonna get a board with that similar issue, probably gonna take 30 minutes as well. And so pretty fast repairs, pretty fast turnaround on those generation. That's very great. It's great for us. It's great for the customer. I really want to, do those repairs as fast as possible. That's when I get paid. I only get paid when the repair is done. And so, obviously, our incentives are aligned with the customer, where we really want to get that fixed as fast as possible. Now, when I get a complete row to put back like that, normally I would use my tweezers, but when it's a complete row like that, I just give myself some time. I place it by hands, and then I start eating and adjust with my tweezers. So you make sure with your fingers that everything is properly aligned. But that doesn't matter too much. It's really to each his own for that kind of stuff. Now remember, sometimes when you put back your heat sinks, the backside, eat is eat, right? So at the end of the day, whenever you eat, there might be something that happens, something that turns out bad. Even if you have the best techniques, it might still happen. So what we'll do is we'll put those heatsink backs, let the dashboard cool down, and we'll test again to make sure that everything is still in place and everything is still working. And let me see if we do have some comments on the channel. No more comments since Sasha. We did have well, not too many viewers at the same time, but we did have some viewers that joined. We get a consistent 6 or 7 average viewers on that stream, so not too bad. Those streams, again, they're mostly watched after the fact for some reason, but we try to do those streams more and more. Maybe at some point we'll even do one per day. We're not there yet, so don't get your hopes too high. But we're trying. It's also a matter of transparency. It shows you how we work. It builds that trust relation, I believe, with our customers. I know that I got some new customers through those streams because they could see that we have the skills to repair those boards. They can see the process we go through to fix those boards. And so it's something I really much like, and it's something, especially the lives, it's something I like because you get to see the real process. It's not just some, edited video where we just show you our victories. We show you what we're thinking. You get to know the diagnosis that we've made, like the first diagnosis we made trying to work on the board. You get to see our thinking process. You get to see the way we work. You get to see the failures we do. So sometimes it happens to the best of us. Sometimes we fail. There's one stream, I believe that's the fourth one we did, where I essentially burnt a part. That happens, and to me it's important to share the failures and the wins with the audience, because it makes us much more true to ourselves. It shows the real background of ASIC repairs. I know a lot of people, they just want to pat themselves on the back and say they're the best. Um, what I think is, I think we're doing everything that's in our power to be the best. I don't think necessarily we are the best, right? There's always something we learn. I think we've been doing that for the repairs, especially like in volumes like we do. We've been doing that for more than 2 years now. And I still think to this day that there's no day that I come to work that I don't learn something. So, and to me, that's the most important. And it's probably why I enjoy doing those streams and enjoy doing those repairs so much, is because I learn every day. Um, so anybody that says to you that they just can do anything and they know everything, I would put a big red flag on that. And especially the ASIC repair industry, it's been plagued with some people that are doing some very bad work, and then it gets to us. I did receive some boards that came back from warranty in China, from warranty in US, that like didn't work. I get some boards back from other repair centers, other repair crews, that don't work. Sometimes we see some very weird stuff, especially from China, where we see like that glue and silicone I was mentioning in the past. Uh, but to be honest, and I did mention that in some previous stream, sometimes they will also be hard workers, very professionals that will do their best to fix your stuff, and they will fix it. But there might be some issue that didn't show up whenever they were looking. There might be some issue during the transport, and so sometimes, even if it goes through a very professional repair center, there might still be some you know, some errors remaining on the boards. Even to us, it happens. I'd say, unfortunately, around 5% of the repairs that go through us are probably going to require RMA. And this is why we offer a 90-day warranty on every repairs we do. So that is correct. 90-day repairs warranty on every repairs we do. So everything that passes through our hands is covered for the next 90 days. Um, I believe we're the biggest warranty out there for ASIC repairs, and that's just how confident we are in our work, and that's just how we're oriented to the customers as well. We want our customers to be happy, we want the customers to have the best experience, and so that's what we're trying to achieve, and that's what we're trying to offer. Oh, we do have Red Zone that's commenting here. Let me see. Hi there, how are you? Can I ask you a question about S19j Pro? I'm trying to repair one as well. Yes, sure, please do, Red Zone. I'm here for still maybe 10 minutes. I have to cool down that board and we'll try it again, see after putting back those back heat sinks if it's still working. So we still have some time to answer your question. Perfect. So while it's cooling down, we'll just put the fan here to make it go faster. Pardon me. All right, so Red Zone is saying, thank you very much. So I have no voltage from the last three chips, 126, 25, and 24. I tried to measure the voltage from the LDO on the back, but there is no 1.8, only 0.8. Um, well, I think it's good news because your voltage for the actually just remember that on S19j Pro it's 1.2 volts. So you're not looking for 1.8, you're looking for 1.2 volt in that case. It yields the same result after I replace the LDO. Sorry about the long message. No, it's my pleasure, man. I really like that engagement, and that's something we want to get more and more. So go ahead and like and subscribe the channel and the video, and we can do more of that in the future. We can help you with more of your issues in the future streams. That said, I would believe that your issue is actually pretty simple because it's the 1.2 volt LDO is fed by the 0.8. So you getting the 0.8 volt, based on our experience here, normally that would not lead to a chip issue. So it doesn't look like it's a chip that's causing your issue. It really looks like it's maybe a capacitor or resistance around that LDO that's your issue. So what I would do is just uncover a neighbor domain and try to, compare the values between my resistance of that domain against the other domain, and see whatever is different, and just change it. So I really think your issue is going to be a simple one to fix. So that's great news. Hopefully that helps. My pleasure, Red Zone. One more thing you can do, if you haven't, I don't know for how long you were in the stream, but you can go ahead and measure the capacitors like I did. You can do your diode measurements as well and see if you can like find any hint there. But really, my expectations is you won't get any weird values there because your problem really is between the 0.8 volt LDO and the 1.2 volt LDO. But if you do see something weird on the 1.2 volt track and capacitors, well, then it might indicate that there's a short on that track, and could be a chip, or could be just anything, a capacitor even that's blown on that side of the board on that very track there. So there are some like other instances that can happen. What I would like, Red Zone, if you don't mind, is let us know once you've fixed your issue. Let us know in a comment on that video what happened to be your issue, and we'll see if if I put you on the right track. So again, make sure my polarity here is good. I can show you here on screen, and just power down my power supply. We'll be able to go ahead and start a new test now that the board is cooled down. And here we have it. So the board is now officially fixed. We just need to put back those, put back some thermal paste here, put back those top heat sinks, and we'll test into the unit. So thank you for watching. Thank you for participating in those streams. It's something I really like doing again. We'll do more of these. We'll do more S19, more S19Js, XPs, everything for sure we'll cover. Any other board you would like us to work on? I know the Watts miners and silicons are requested. I obviously try to do those streams in a way that's also making us process the boards from our customers. So I try to have some of the best lead times for our customers, and so I'll try to always match something that we get sent with those streams. So it's not always possible for me to pick and choose any board. I try to go with whatever is relevant, and so right now I believe 19 series D7 L7 is what's relevant at the moment. It's what's profitable. S17 Plus we did some also because they're still profitable units. I still to this day haven't got a T7 Hashboard that got fixed on stream, so we might do that just for the form. But they're less profitable right now. I don't think there's too many incentives to fix them right now. While although we did see some increase in the past days of requests for 17 series, so I think there's miners are definitely expecting the market to turn around real soon, and it's felt. We can definitely feel it with hosting requests and repair requests as well. We have one of our partners right now, business development, that's doing development in Paraguay, and there's a lot of, hopefully we'll have a lot of stuff to announce real soon. And so until then, thank you all for watching. And yes, Natal, I just saw your comment. We'll do a live on fixing the control boards, but do note control boards are a bit more tricky. The thing with control boards is most of the time it's going to be a component that's shorting, and so you really have to get on the hunt for those shorts. With the hash boards, it's almost always a ASIC chip, so you just or LDO or something like that, where you always get the same kind of of diagnostic methods, and once you know them and you process them, it's just some kind of rinse and repeat. The control boards, they're definitely doable, and I've started, to do some of those repairs. But they are more tricky because, like, each control board I fixed essentially was a different problem. So you really have to be on the hunt. So, like, it probably won't uh, be as useful for you to watch because you're gonna need to, like, you really have to get good with understanding like really the really core of electronics and just follow the logic, right? So the way I fix my control board so far is I look at my issues. So for instance, I have a fan issue. Well, I look at my fan port. I would measure each of my pins and compare against a good board, right? And then whenever I see a pin that has the wrong values, I would follow that until I get to the source, and then I could change that part and would get my control board working. Same goes, for instance, if you have networking issues. Well, it might be your CPU that's broken. In that case, it's going to require either a CPU replacement or reballing and reinstalling, or it might be anything that's in between of that network IC chip. Or so it can be the network chip, or it can be anything in between, is what I meant. So it can be resistance, capacitors. Really, it just you just have to do it. It's the best, but for sure I'll do some live streams about that as well. Thank you for the suggestion. So again, thanks you all for watching. Please go ahead and subscribe and like. It helps us get more reach. If you need any repair parts, you can go on our shop. You can make a custom quote through our support. And that's it for today. Thank you all. Bye bye.